Good evening, students. In today's class, we are going to learn about the basics of nitrogen fixation. Here, we can understand the fact that the nitrogen plays a vital role in the ecosystem. The nitrogen is one of the preliminary or foremost important nutrient for the survival of all the living organisms. It is believed that the nitrogen constitutes about 78% in the Earth's atmosphere. Here, the nitrogen is present in the form of nitrates or nitrates, plays a vital role in the biogeochemical cycles, atmospheric precipitation, geological sources, agricultural lands, livestock, poultry farms, mineralization of organic components, and this acts as a major source where we have many nitrogenous compounds as well. How important is nitrogen for the plant growth? To play as a key enzyme for the production of amino acids, key components for the production of amino acids, which acts as a building blocks of photosynthesis of various proteins and enzymes. This macronutrient plays a vital role in the plant growth and its active metabolism. The structural materials are made up of nitrogenous compounds, but it also involved in the makeup of the cells or the composition of the morphological structure of the cells is constituted by nitrogen. As we all know, nucleic acid, vitamins, and hormones have many nitrogenous components for the production of vitamins at a proper rate. Nitrogen plays a very important role. It is also a part of the protein, NAD, and other alkaloids require a high amount of nutrition. The genetic components or the metabolic components of the plant, where nitrogen is a major component of it. Nitrogen always exists in the environment as N2, which means between the two nitrogen molecules there is a triple bond. This is a very recalcitrant form at which it is present, which cannot be used for the elements. That's when the economically important nitrogen fixing bacteria which will get a picture. They have the ability to convert this recalcitrant form of nitrogen into a user-friendly form. That is nothing but its ability to convert into nitrites and then nitrates, which is the usable form to the plants. The enzymes that are produced by these nitrogen producing bacteria has ability to fix nitrogen to the higher plants, which is a simple way to give adequate amount of nitrogen to the plant for its active metabolism. Nitrogen fixation process usually happens in this way or one of this way. Here we have the nitrogen fixation happening in biological form, also in non-biological form. As in, here in biological form, there are living organisms that are involved in the nitrogen fixation, whereas in the physical form or the non-biological form, there are no such organisms that are involved. When we speak about the biological process, which can be classified further as symbiotic biological nitrogen fixation, non-symbiotic biological nitrogen fixation. Again, the symbiotic can be classified as through migration and through non-modulation. This is the nodes that are involved in the nitrogen fixation. To speak about the non-biological or the physical method of nitrogen fixation is nothing but the lightning process, whereas the lightning enters inside the Earth atmosphere, there is a good amount of nitrogen that is given inside the Earth, which is taken up by the plants. This very small amount of lightning or UV radiation can fix a good amount of nitrogen into the atmosphere, which produces nitric oxide. To speak about the nitrogen fixation using physical methodology, which can be correlated with the acid rain formation. As we all have heard about the acid rain, this is hand in hand with it. First of all, the nitrogen is being liberated inside the Earth's atmosphere, which contains oxygen. In the process of lightning, nitric oxide is being formed. When this nitric oxide reacts with the atmospheric oxygen, Nitrogen peroxide is being formed. Now nitric oxide and nitrogen peroxide is in the environment. When we contain this nitrogen peroxide is acting on the moisture content that is there in the environment, that is the rainwater, that converts it into HNO3 and HNO2. Then this is nothing but the acid rain, that is what we are speaking about. This is nothing but the acid is coming as such. It is nothing but a combination of the rainwater with the acid that is left out in the environment. These HNO3 and HNO2 in combination with the salts that are there in the solvent, there are several potassium nitrates or potassium nitrates that are deposited as a form of salt in the, as a salt in the, as a form of salt in the soil. This is how the acid rain is being formed. There we have other several types of biological nitrogen fixation that exclusively happen under the influence of the nitrogen fixing organisms. It is not just fixing, it can also be fungi, it can also be actinizer, it can also be some other higher organisms. They are the ones who have the ability to convert the ammonia into nitrites and nitrates and make it a deposited form for the plants to utilize them and make use of it. Here, this biological nitrogen fixation process is further divided into symbiotic nitrogen fixation and non-symbiotic nitrogen fixation. Symbiotic nitrogen fixation represents the mutualistic relationship between the nitrogen fixing organism and the higher plants. These plants tend to be benefited as well the microorganisms are also benefited. That is why we call it symbiotic nitrogen fixation or mutualistic relationship, where plants get adequate amount of nitrogen from the microorganism, whereas the root exudates that are produced by the plant, the root hormone that is synthesized by the plant acts as a major nutrients for this microbial metabolism process. So they both work hand in hand in a mutualistic relationship and help each other. Here, this symbiotic nitrogen fixation is further divided as nitrogen fixation through nodule formation and nitrogen fixation through non-nodule formation. This nitrogen fixation is a process through nodule formation is a process where there are certain process in which the nodules are being formed in the higher plants under the influence of nitrogen fixing bacteria. Nodules are present inside the roots or produced in the node region of the roots, which creates a perfect habitat for the organisms to live there or to convert a good amount of nitrogen into user-friendly form. That is nothing but the fixing of the adequate amount of nitrogen can happen under the influence of a proper nodule formation, because it creates a typical habitat for the fixation to happen. The typical habitat is what I'm speaking about is the enzyme that is involved in nitrogen fixation process, that is nothing but the nitrogenase enzyme. The unique characteristics of this enzyme is believed to be its oxygen sensitive character. This enzyme is believed to be highly oxygen sensitive, so this nodule region is believed to be anaerobic in nature. This aids in providing a typical appropriate environment for the nitrogenase enzyme to convert the ammonia to nitrites, which you can help in the fixing in the higher plants. The best example for nodule formation is the rhizobium species. Here we have the plant which has the roots are believed to contain the nodules, which these nodules are produced in the roots of the higher plant under the influence of the rhizobium, which is nothing but the nitrogen fixing organisms. Initially it gets adhered to the nucleus, this rhizobium gets adhered to the nucleus, and then the infection code is being formed with the cortical region of the roots, where more and more bacteroids are being formed, which later produces a bunch or a node structure of the, which is nothing but the nodules. So this can be further explained in a clear way. This is the typical structure where you have the venous plant, where the rhizobium gets attached initially into the root hair. This root protein consists of a lot of ribosome. There is a presence of non-factor activation that is happening to know the gene that is present inside the bacteria, which makes it enabling it to produce more in the root hair. Here, this more gene are going to activate the more factor of activation is being produced in the more gene activation. This production of the more factor it produces a clearing of the root hair, and then the infection curve is being blocked, and then more and more bacteria form the ultimately a nodule is being formed, which acts as a affected and non-affected bacteria to strike there. So this is the infectious spread that can be released the microscopic review how exactly the nodules are being formed, the structure of nodule can be formed. So what are the factors that can affect the nodule formation? Can be the external factors such as heat, acidity, or nitrate content in soil. If the soil is highly rich in nitrogen content, it will replace with the nodule formation. As we all know, only under the less nitrogen, the lesser the nitrogen in the soil, the more will be the nitrogen fixation. So the more the presence of nitrogen will inhibit the nodule formation. Nitrogen fixation is a highly sensitive process, as we all know. So the presence of oxygen can interfere with the nitrogen fixation process. There is a pigment such as hemoglobin, which facilitates the diffusion of the oxygen. Here also we can speak about the autoregulation that is shown by the lymph tissues, where this rhizobium is detected as a foreign material. So the plant immune system tries to advance with this nitrogen fixing organisms. Also, thymine, which is nothing but the ripening enzyme, can also regulate the nodule formation externally. Now, what is this nodule fixation using non-leguminous plants? Nodule formation usually happens in the leguminous plant. Whatever the non-nodule formation of non-leguminous plants, also like Frankia can produce, the nodules are produced in association with leguminous. Rhizobia also produces in non-leguminous plants such as the Panispermia, and also Textula can produce of the nodules. So this is how the animal species are producing nodules here, or the Panispermia species producing spores in the plant. Nitrogen fixation through non-modulation process. In case of leguminous or non-leguminous, modulation process is same. But what in case of non-nodule formation, how the nitrogen could be fixed? The best example could be algae, which is nothing but a combination of algae and fungi. Here, the fungi absorbs all the essential mineral nutrients and make it available to the algae, where algae is a photosynthetic nature can synthesize its own food and feeds the fungi as well. And the anthoceres fixes under the influence of nitrogen. Azola and Amidina, excellent symbiotic relationship can be seen. Cypress in the relationship with Amidina or Moscow, or the sorghum in relationship with cyanobacteria, that is the spirulum. Because the cyanobacteria with the relationship with these higher plants make them makes the nitrogen available for these organisms. So non-symbiotic nitrogen fixation can be further classified as free living aerobic nitrogen fixing bacteria, free living anaerobic, free living chemosynthetic, cyanobacteria, that is the medium idea of free living fungi. So here we have the examples corresponding to the different type of organisms, so that is the fungi or the bacteria that is involved in various type of nitrogen fixation. So this summarizes how nitrogen can be fixed in leguminous plants, non-leguminous plants, that is in the symbiotic association. Also in non-symbiotic association, how nitrogen can be fixed, how the atmospheric nitrogen is made easily available to the higher plants. Thank you.